Hello, welcome back for the practical session of Technology of Inorganic Chemicals. In this session, we are going to study or going to perform the practical of determination of percentage purity of sodium hydroxide. For this purpose, I have measured 2 grams of sodium hydroxide and preparing a solution of sodium hydroxide of 255 ml quantity. So here I have mixed this measured quantity of sodium hydroxide and dissolving it in small quantity of solvent, that is water, and transferring it into a volumetric flask. This test sample will be used for the experimental purpose. Here, a simple principle of neutralization is involved, and we are using this neutralization principle for the volumetric analysis. And for titration purpose, we are using 0.1 normal HCl solution as a standard solution. While preparing the test sample solution, ensure that all the sodium hydroxide measured quantity, that is 2 gram, will be completely dissolved in water, and total quantity is available for our experimental process. So dissolve this NaOH in a part of small quantity of water. Here you can observe no traces of NaOH is present in volumetric measure beaker. Now add additional water to volumetric flask to make up the volume 250 ml. By addition water up to 250 ml mark. Okay. So here I have prepared a solution of 2 gram of sodium hydroxide and will transfer a small quantity in a beaker for experiments. So this is a test sample of sodium hydroxide. This solution is 0.1 normal HCl, which will be used as a standard solution for volumetric analysis, that is titration. Here I am transferring this standard solution in 25 ml capacity burette. Now we have to take a little quantity, that is 10 ml of this prepared solution for the titration purpose. So pipette out 10 ml of prepared NaOH solution. So I have pipette out 10 ml of prepared NaOH solution. Now we will transfer it into a conical flask. As the acid, that is HCl, and the test solution, that is NaOH, both are strong in nature, so we can use phenolphthalein indicator for indication of the complete neutralization. After addition of phenolphthalein indicator, the solution becomes pink, as phenolphthalein indicator gives pink color in alkalis. So therefore, the end point of this experiment will be pink to colorless. So now we will titrate this test NaOH sample with the standard solution, that is 0.1 normal HCl. We will add HCl from burette in controlled rate, that is drop by drop, to ensure the correctness of the experiment. So at this stage, the pink color is disappear, and after continuous mixing, it is not reappearing. So this is the end point of this experiment. So the reading for first trial is 17 ml. So burette reading is 17 ml. Now we will confirm whether this reading is correct or not. So we will repeat the process for 2 more times. First, pipette out 10 ml of prepared NaOH solution. Add 2 to 3 drops of phenolphthalein indicator. Refill the burette with 0.1 normal standard HCl solution. and continue titration. Here you should continue the titration with addition of standard solution drop by drop. Do not rely on previous readings, as the previous reading might have wrong one. So while repeating the process, continue the process as you are performing the experiment at first time. So don't rely on previous readings. So at this stage, the pink color is disappeared and the burette reading is 16.8. 16.8. So we will again perform the same titration for the correctness of experiment. Ten ml of prepared NaOH solution, two to three drops of phenolphthalein indicator. Refill the burette with 0.1 normal standard HCl solution. Titrate it with standard solution. Again, ensure that the addition of standard HCl should be drop by drop. Here at this stage, the color is disappeared and the burette reading is 16.9. The burette reading is 16.9. So, as in this case, we do not have the constant burette reading, so we will use the mean burette reading, means mean of all these three readings. So for calculation purpose, take the mean of all these three readings. So in next session we will do the calculation part. Hello, welcome for the calculation of the experiment to find the percentage purity of NaOH. In this experiment, we have used NaOH as a test sample and HCl, that is hydrochloric acid, as a standard sample. So the reaction between NaOH and HCl is NaCl and H2O. NaCl is a salt and water, both are neutral in nature. So therefore we can use the relation between NaOH and HCl as 1 mole of NaOH is equivalent to 1 mole of HCl. And from this equivalence relationship we can write the formula N1V1 is equal to N2V2, where N1 is the normality of NaOH solution, V1 is the volume of NaOH solution, N2 normality of HCl, and V2 volume of HCl. So from this we have to calculate the normality of NaOH, that is N1. So the formula will become N2V2 upon V1. So normality N2, that is normality of HCl, which we have taken as 0.1. The volume of HCl, that is the burette reading, and from the experiment, and that reading was, first reading was 17 ml of HCl, second reading was 16.8 ml of HCl, and third reading was 16.9 ml of HCl. And in this case we do not have the constant burette reading, so we will use the mean of these three readings. So it will become 16.9 ml of 0.1 normal HCl. So means for neutralization of 10 ml of prepared sample, NaOH sample, the volume of HCl required was 16.9 ml. So V2 is 16.9. Now this V1 is the volume of test sample, that is prepared NaOH solution, and which we have used 10 ml for each reading. So after solving this relation we will get 0.169 normal. So the normality of prepared NaOH solution was calculated as 0.169 normal. So from this normality we have to calculate the strength of NaOH solution, and the formula for strength is normality into equivalent weight. So what calculated normality is 0.169 normal, and the equivalent weight of NaOH is 40. So after solving this equation we will get the strength at 6.76, and the unit is gram per liter. This strength indicates that 6.76 gram of NaOH is present in 1 liter solution. But remember that we have not prepared the volume of NaOH to 1 liter. We have prepared it 250 ml. So therefore we have to divide this quantity by 4, and after division of this quantity by 4 it will become 1.69, and the unit will be gram per 250 ml. This calculation indicates that 1.69 gram of NaOH was present in 250 ml prepared NaOH sample. So we have to calculate these experimental findings with the theoretical quantity to find out the percentage purity of NaOH. So the formula will be practical quantity of NaOH upon theoretical quantity of NaOH into 100. The practically calculated quantity is 1.69 gram, and the theoretical quantity which we have taken 2 gram for preparation of the dilute solution into 100. And after calculating this equation we will get 84.5%. So this is the purity of NaOH which we have taken 2 grams for preparation of the solution and for the purpose of finding the purity of NaOH. So this is the simple procedure to find out the percentage purity of NaOH. Thank you.